Here we have the full STM32 portfolio. From the top down, that's our MPU portfolio, high performance MCUs, mainstream MCUs, ultra low power MCUs, and wireless MCUs. In yellow, we have new series or lines that were introduced in 2024. And in purple are devices that we demoed or announced at the recent Embedded World Conference. That includes devices like our newer STM32 MPU, the STM32N6, which is an M55 microcontroller with a neural processing unit, and the newest ultra-low power processor, which is the STM32U3. Today, we're going to talk to you about the STM32U5, which is also a low-power microcontroller with a 160 megahertz Cortex M33 core. Here are some of the key features of the STM32U5 series. First and foremost, we have the high energy efficiency. Some innovative power management features, including our low power background autonomous mode, DMA, and IP autonomous and low power modes. The power efficiency of the STM32U5 devices allows us to go as low as 16 microamps per megahertz up to the full performance of 160 megahertz Cortex M33 core. We have a high level of integration across the series that includes up to 4 megs of internal flash memory, up to 3 megs of RAM, the USB high speed with integrated PHY. On the security side, we have an AES and PKI engine that has side channel attack resistance and ECC on both flash memory and SRAM. You'll see on the coming slide, we do have devices with some advanced graphics accelerators. That includes our Neochrome and Neochrome VG GPUs, and improved data storage in the flash that allows for up to 100,000 read-write cycles on 512 kilobytes of the flash memory. Here we can see how the STM32U5 stacks up against our other low-power microcontrollers when it comes to processor performance across the bottom and memory size across the left column. The newest devices in this family include the STM32U0, which is a very low power and low cost Cortex M0 Plus microcontroller. Then the newest release device, which is the STM32U3, based on a near threshold technology to make it our lowest power microcontroller. And then the device we'll be focusing on today, which is the STM32U5, which gives us our biggest breadth of memory density and highest performance in the low power family. And here we can see a more detailed view of the full STM32U5 portfolio. It goes into some of the features and peripherals of each individual subseries. We're going to focus on the second column, which is the STM32U575 and U585. You can see this includes 1 to 2 megabytes of flash, 786 kilobytes of RAM, a USB full speed with power delivery controller, a 12-bit ADC, 14-bit ADC, SDIO, FSMC, and 2 octal SPI interfaces. We also have SPI and parallel 8080 interface for display with our ChromeArt accelerator and packages ranging from 48 to 169 pins. To the left of that, we have the U535 and U545, which removes a few of the peripherals and capabilities, but is still a very high performance device in this ultra low power family. And as you go to the right, you can see we start to add more features, more memory, and some more advanced graphics capabilities, including larger package sizes as well. In the next slide, I will show you a block diagram of the most fully featured U5 device. And based on this table here, you can see you can choose the device that best suits your needs. And here we have the block diagram of the most fully featured STM32U5. All of the U5s are based off the 160 megahertz Cortex M33 core that does have a floating point unit, memory protection, and trust zone enabled on the device. Depending on the series, the U5 device selected, you do have some options for a GPU accelerator that can also support vector graphics. We have a low power DMA, an FMAC and Cordec DSP accelerator, ART accelerator that works in the background to help with graphics, and up to 4 megs of flash and dual bank configuration and 3 megs of SRAM. We have a parallel interface with a flexible static memory controller that can support 8 or 16 bits for LCD, SRAM, NOR, and NAND. Some of the devices do have a MIPI DSI display controller. We also offer a JPEG codec on some of the devices. We have a wide range of timers, including advanced motor control timers, low power timers, and general purpose timers. Some additional IOs for our touch sensing controller and camera interface. A wide array of connectivity options, including USB high speed with PHY, on the go, and power delivery. 2 SDIO interfaces, 3 SPI, 6 I2C a CAN interface, 2 octal SPI, 1 hexa SPI, 6 UARTs, and 1 ultra low power UART. A number of digital peripherals as well. This includes our crypto engines like the AES and SHA, algorithms, a true random number generator, serial audio interfaces, and digital filters as well. You'll get a mix of analog depending on the device selected, but we do have up to 2 14-bit ADCs, a 12-bit ADC, 2 DACs, 2 competitors, 2 op amps, and a temp sensor. So as you can see, it's a very fully featured device. Again, depending on your needs, you can select the device that best suits your needs. Here we have some industry standard benchmarks from the EMBC organization. This includes the ultra low power mark CP, PP, and CM benchmarks, which is a good analysis of the true energy cost of the device when you're in a deep sleep state, the peripherals use when on in deep sleep, and then the active power using core mark as a workload. And then the final one here is the efficiency of the crypto processing engines, which is the secure mark TLS benchmark. These are good published numbers, so you can really do an apples to apples comparison when making your selection for the microcontroller best fits your application. And you can find these numbers posted on EMBC's website as well. A big part of our STM32 ecosystem is our STM32 CubeMX tool. This is a key tool that we offer to our developers to help do things like part selection, pin initialization, peripheral configuration, code generation, and other very useful features. I wanted to highlight it because I feel it's a very strong tool for our developers to use. In addition to that, with the U5 series, we introduced a new feature called the low power background autonomous mode tool. This allows you to enable some of those very low power features that are available now in the STM32 U5 devices. In addition to the LP BAM tool, we also have a power consumption calculator that gives you very accurate power consumption numbers based on your device usage. And part of the tool also includes the software components and parameters. And as part of that, we actually do have the wolfSSL tools built into this tool as well. This allows you to very quickly and easily get up and running with the wolfSSL solutions on STM32 hardware. We've been happy to be working with that wolfSSL for a number of years now, and they've made their tools and resources available inside our CubeMX tool as well, again, to help facilitate your development and hopefully faster and easier, I should say, development time on the STM32 platform. If you haven't had a chance to play with the STM32 CubeMX tool, I encourage you to go and download it. It's pretty easy to install and play around with. You can also go and install the wolfSSL tools as well. And if you have an STM32 board, you can also start with that board selection and get up and running very quickly with the processors, the boards, example projects, the wolfSSL tools, and really start digging into the devices and configuration available within the tool. I hope you find the tool as helpful as I have when working with the STM32 ecosystem. And this is the last slide I have for you before I pass it back to Anthony. This is just a slide showcasing some of the advanced security features that are available in the STM32 U5 family. On the isolation side, we have Trust Zone that's available on the M33 core. Along with that, we have secured peripherals and a secure DMA. On the crypto side, we have the AES and PKA engine that do have side channel attack resistance. We have additional AES, PKA, SHA engines as well with a true random number generator and a CAVP certified crypto lib that will run on the U5 series. The U5 family is certified up to PSA level 3 and CSIP level 3 certifications. We have some advanced readout protections that have 4 protection level states with password-based regression, a number of different memory protections, including one-time programmable memory, write protection, readout protection, the memory protection unit. We have an on-the-fly encryption decryption engine for the flash, and we also support secure debugging on this device. And on the tamper side, we have 8 IOs that are capable of tamper detection that can be paired up to do active tampering, 4 pairs of active tamper pins. We also do voltage and temperature monitoring. In addition to that, we have our Trust Anchor, which is TFM, which is trusted firmware. For microcontrollers, this helps support things like secure boot and secure firmware install. And we also have hardware unique keys. So you have a unique set of identification numbers on every single device as well. The features highlighted in bold are new as of the U5 series release. Some of the bigger highlights here include the side channel attack resistance, the secure debug functionality, and also the more advanced readout protection on the memory with the password-based regression. As you can see, we are constantly improving the state of security on our microcontrollers, and the U5 is no exception to that. So working with these hardware features in addition to the software features that wolfSSL can provide, we hope we can meet all of your security needs. That's it for me. Back to you, Anthony.
All right, so yeah, thank you, Mena. That was really, really great. A great introduction. So yeah, my name is Anthony Hu, and I've been a member of the wolfSSL team for approximately almost 4 years now. And but I've been doing, consumer electronics and various other software development for about 20 years now, maybe 25, somewhere in there. So let's talk about post-quantum cryptography and the motivation as to why we do this. Is it quantum computing? Is it CRQCs, a cryptographically relevant quantum computer? When are we going to have one, and who's going to get it? And the answer is it's not really relevant. We don't really want to worry about this sort of thing because all it does is cause uncertainty and loss of motivation when it's uncertain. What is certain is that standards organizations such as NIST, the NSA, the IETF, and various other organizations are all on board with this. They are all moving forward with this, and we need to keep on going with it. We don't need to question when a quantum computer is going to become a reality. We need to be already prepared when it does. So we have to talk about threat models such as harvest now and decrypt later, which is the idea that your data has a lifetime. So if I can hoover up your ciphertext, and a quantum computer becomes a reality within the amount of time that your data needs to stay confidential, then you're in trouble. Now, the deploy now, forge later threat model is that you might have a device somewhere remote that you might find it hard to get to update, or find it hard to, find it hard to access. We're talking things like, oil rigs or windmills in the middle of the ocean, or even space. So, if you can't update them, then you kind of need to have the best encryption you can have right now. So another motivation is the CNSA 2.0 timeline. If you look at it, it's pretty aggressive. We're already in 2005 right now. And what does that mean? That means that these algorithms that we're talking about, these post-quantum algorithms such as ML-DSA, ML-KEM, XMSS, and LMS, should already be the default and preferred algorithms in firmware signing, and as well as web browsers and cloud services. Note, on the other side of that line, 2030 is when it should be exclusively CNSA 2.0 post-quantum algorithms. That means nobody wants to see ECC in a software firmware signing application. So where are some gotchas? DTLS 1.3, not DTLS 1.2. So you got to understand that no new cipher suites will be defined for DTLS 1.2 and TLS 1.2. Why is that? Because they're not adding new cipher suites to TLS 1.2. They're only adding new groups and new SIG-out code points in TLS 1.3 and DTLS 1.3. So if you're still using either DTLS or TLS 1.2, at least the best steps you can take right now today is to get to TLS 1.3. So wolfcrypt has our own implementation of LMS XMSS, ML-KEM, and ML-DSA. These are recommended by both NIST and NSS CNSA 2.0 suite. So LMS and XMSS are both stateful hash-based signature schemes. They feature small public keys, fast verification, but larger signatures, and they're appropriate for wolf boot. For supported code points in TLS, we have the following. The first three are for ML-KEM, and the last three for supported groups are hybrids of ML-KEM with the appropriate level of ECDHE. For SIGALGs, for the SIGALGs TLS extension, the supported signatures is ML-DSA, and it's at 3 different levels of security. Okay, let's talk about the demo. So here it is. Here's the Nucleo STM32U575ZI-Q development board. It features a Cortex M33 with trust zone on it. The demo we're going to be doing on it is post-quantum TLS 1.3 with ML-KEM level 512 over UART2. UART2 just means that it's the port that is connected to the one of these black headers. You can find out more about the evaluation this board at the link given here. And by the way, these slides will be available for download. So after the webinar, please do get in contact with us via fax at wolfSSL. As I was saying, this is the actual board in operation. You can see where we connect to the various connectors for the demo. So let's talk about the actual project setup and software setup. So yeah, if you've ever worked with wolfSSL, this should all look pretty familiar. First, you click on wolfSSL, you pick your version. In this case, we're using 5.7.6. And you tap your install. Right now it's faded, but once you've got it properly selected, it will be clickable. So once it's installed in your project, you have to specify which wolfSSL components you'd like to use. And in this case, you'll want all 3 that are under wolfSSL. So the wolfSSL core, the wolfcrypt core, and the wolfcrypt test. And then you just tap install and OK. Right, so once you've got that installed, you're going to need to go into the middleware and software packs and select i-cube-wolfSSL. And you're going to want to turn on single precision assembler for Cortex M3+. You're going to want to turn on SHA-3, and you're also going to want to enable Kyber ML-KEM post-quantum ciphers. Now, this is for the connectivity part of the demo. You're going to want to look into enabling USART1. It should be already enabled by default. And that's just so that you can get the debug output on screen. You're going to want to enable USART2. And that is for, of course, the communication, the TLS communication over UART. Note the pinouts are PA2 and PA3. That's very important because that maps to what you saw in the picture earlier. You're going to want to turn on an RNG because, well, RNGs are somewhat important. Joking aside, they're very important. So please do turn on your RNG. Make sure it's activated. In system core, you're going to want to configure GPDMA1. This is important because it's somewhat of a newer concept within the STM32 configuration system. There were different ways of configuring DMA in the past. Yeah, so you're going to want to make sure that channel 1 is set to USART1. Channel 2 is set to USART1 RX, which is receive. Channel 2 is set to USART1 transmit. Channel 3 is set to USART2 receive. And channel 4 is set to USART2 transmit. Okay, so in the channel 1 configuration tab, you'll make sure that request says USART1 RX. Channel 2 says USART1 TX under request. Channel 3 says USART2 RX. Now this is really important. This isn't needed for any of the other ones, but it is needed for USART2 RX, which is the destination data setting. And the destination address incrementer should be enabled. Again, it's not needed for any other channel, just this one. And for channel 4, the request should be set to USART2 TX. Okay, and set the H clock to the max. Oh, sorry, you should go to your clock configuration. You should set H clock to its maximum value. And as it says there, it's 160. So we put 160 in the box. And then we tap the resolve clock issues. This makes sure that you're running at the best performance. Okay, so those are all the IOC configurations. After making all those adjustments and installing all the stuff, you would then generate code. And after you generate code, there are certain additions that you have to make by hand. So in wolfSSL iq-wolfSSL_conf.h, we need to comment out the no TLS UART test, or remove it. You can comment it or just remove it. And there you have to define TLS_UART as HUART2, the handle for UART2. In the same file, you're going to have to go and find, find wolfSSL no shake 128, and you're going to have to add those kind of guards around it. And in your main.c file, you'll have to add some headers. So you'll need stdio.h, wolfcrypt settings, and the wolfSSL_example.h header file. Right, so we need this here. This allows us to actually output to the console. So when you plug in the debug, when you plug in the USB debugger into the board, you'll actually see the stuff go to your terminal. And this is all documented in the README within wolfSSL for STM32 products. You'll also need to add this, and you know where to put it. You'll know where to put it because you can just search for user code begin init, that comment is already inside your main.c file. And just to test to make sure it actually does what you think it should be doing, you'll add hello there. And this is a print, so you'll just add a printf hello there, so that you definitely do see that. And then you add wolfcrypt demo. So wolfcrypt demo actually goes into an infinite loop, and that will kind of go through an infinite loop that's in a menu system that allows you to run different applications. Right. So there is some sort of weirdness within the IDE, and you have to add a little bit of code for the button handler. If you look at I put a comment there to where I got basically a place that explains why I had to add this there. Okay, now it's demo time. So as I was explaining, the wolfcrypt demo function is just an infinite loop that prints out this menu and waits for the user to kind of give it input. And the user gives input, and that input will select which of these applications are run. So if you were to pick wolfcrypt benchmark, for example, you would see this particular output coming out. And it's very interesting output if you really pay attention to where I've got the arrows. When you look at the performance, we're looking at 150 operations of keygen for ECC is 1 second. For the equivalent security level of ML-KEM, which is ML-KEM 512, you can get 74 keygens within 1 second. So, you know, it takes about you can get double the number of keygens from ECC. So the performance isn't bad. Keep in mind that we didn't focus on ARM all that much in terms of building, in terms of optimizations for ML-KEM. We mainly focused on x86 64. And there's still a lot of room for improvement moving forward. So that's a priority for for people. They can let us know, and we can definitely improve those numbers. Worthy of note is that encapsulation and decapsulation are basically on par with ECDH's agreement function. Okay, so on the Linux PC side, we've got, so yeah, this demo is interesting in that what's happening is we're doing TLS over UART, but when you do it over UART, there has to be something on the other side. And in the previous picture where you saw the board, you could see that it had a TTYL connector, and that TTYL connector connects to a Linux machine. So you have to build wolfSSL on the Linux machine as well. And these are the instructions for doing so. So when we do this, we have a Linux PC, like I said, over UART and USB talking to the STM32U5 client. And so on the PC side, we would execute the server. Now we have to do this with sudo because it's talking to a serial device, which means that you need root access. And as you can, and so these what you see on the screen here is the output for on the PC side, Linux PC side, as well as on the on the STM32U5 side. And similarly, we can do it where the STM32U5 is a server and the Linux side is a client. And again, we have to use sudo because we're talking to a terminal device. Okay, and that's the end. Thank you very much.
Wonderful. Well, thank you, Anthony and Mena. To kick off the questions, could you please elaborate on the harvest now, decrypt later threat model? Sorry.
Yeah, so this is Anthony again. Harvest now and decrypt later, it can be kind of confusing because there's various timelines and various like variables. So I can elaborate on it by talking about what it's not. It's kind of what I'm about to give is I don't like to give really scary examples. I like to kind of give trivial examples and then let people kind of give their own put themselves and their own situation into that template. So, for example, when we talk about harvest now, decrypt later, a kind of trivial example is my daughter's birthday party, right? So I have a secret, a piece of confidential information, which is that I'm planning a secret birthday party for her. And what's the lifetime of this secret? Well, it's going to be the day of her birthday, right? Once her birthday rolls around, we know she's going to know she has a birthday, so the value of that confidential information goes to zero. What are the consequences if I if somehow she has a secret birthday party and that's revealed to her? What are the consequences? Well, she learns that she has a birthday party coming up, so it's not that big a deal. And so when we look at that example, we can see that there are a couple things in play. It's how long does the data need to stay secret for? And what are the consequences if it doesn't stay secret? Obviously, no one's going to, build a quantum computer to figure out the secret date of my daughter's birthday party. But, in your situation, what are the consequences if your confidential data becomes known to adversaries? And what is the lifetime of your confidential data? I hope that makes things a little bit clearer and doesn't scare anybody. Remember, quantum computers are not a boogeyman.
I've seen a few of you raise your hands. Please just send your questions into the Q&A box. That way they will all get answered. Kind of moving on, what sort of performance improvement could we expect with the wolfSSL suite running on the U585 instead of the U575 hardware?
Yeah, I think I'm gonna have to leave that one to the STM expert here. Mena, would you be able to take that one?
Yeah, I don't know if I have a specific answer, but the 585 does include the hardware crypto module, which will obviously help us get better security performance numbers. I don't have any specific benchmarks running with the wolfSSL tools to give you specific numbers. We have our own crypto lib that runs some security algorithms, and we do post benchmark numbers for that on our wiki site. I could probably dig up the link and get it back to the team. I can try and include it today if possible. We can follow up with that. But yeah, in general, you'll see a pretty big improvement when you incorporate the hardware crypto module on top of all these security features. Again, if we don't have the hardware available, we do it in software. It just takes more clock cycles. But if you need that extra speed, the 585 is there to help you out there. Hopefully that helps answer the question.
Yes, wonderful. Thank you. Well, I think those were all of our questions. Please feel free to email us at facts@wolfssl.com if you have any other ones that kind of pop up after this webinar. Thank you, Anthony and Mena, for hosting a very informative webinar. Thank you to everyone for joining. I will email a copy of the webinar recording and PDF slides. You can keep up with our upcoming events, meet our team in person, read our blog posts, and get the latest wolfSSL updates by following us on X, connecting with us on LinkedIn, and subscribing to our YouTube channel. If you have any questions, please reach out to us at facts@wolfssl.com. Thank you again, and we look forward to seeing you on May 1st for our wolfSSL and Weston Embedded interoperability partners in the IoT space. Thank you.